Okay, here's a question about a continuous random variable x, but look, it tells us, it names that distribution so we know where we're on. We've got a particular range of values, 0 to some b that we don't know. We've got to write down the expectation of x. Now if you sketch the graph, it's obvious what the expectation of x is, but I suppose you could use the formula from page 11. No working needed for that. But then we have to do a proof using integration of this variance formula. So you can't use the standard result for the rectangular distribution in this case, you've got to establish it, but you can start from the other formula on page 11, the integration formula for variance of x, otherwise known as sigma squared, which you get by an integral with an x squared in it minus something else squared over here. So this integral here, you just set up, there's your f of x that you need to plug in there. Put in the limits 0 and b, so the answer will come out in terms of b, and when you put these two things together you should be able to work out that result and the answer is given. If you couldn't do that, of course, don't give up on part B. This is a re-entry point. At an athletics meeting, the error in seconds, blah-de-blah-de-blah, it can be modelled as this. All we've got to do is calculate the probability of the modulus of t being greater than 0.02. Now modulus means the value after we ignore any minus sign. So there are two, if you like, cut-off points here. One will be at 0.02, and all values greater than that will be okay. But the other possibility is related to minus 0.02. So there are other places you could be in relation to that. So they'll end up being two separate areas to shade on your sketch that you total up to calculate that probability.